So hello guys, good morning. I am Erica Maybasa. Today I will be discussing the one-way ANOVA. So to discuss the one-way ANOVA, we have two major parts of it. So the first one is the steps in calculating one-way ANOVA between groups. And the second one is using ANOVA within statistical logic. Now, we always have to remember the following. So in the previous discussion, I already read this to you, and you can go back to this slide for you to remember the terms that we needed in calculating the one-way ANOVA between groups. Now, we have here a table wherein we need to fill out. Yes, we need to fill that out. And for us to know how to fill this table up, we need to have first our, of course, data. So in our data, we have 12 students and 3 groups. So I already discussed this to you as well. So now, we will just be going to the calculation of the one-way ANOVA. In the calculation of one-way ANOVA, the step 1 is we have to calculate the SST. Now, what is an SST again? It's the sum of total squares. So, we have to calculate the sum of total squares. Now, we have this formula here. The summation of x squared minus open parenthesis summation of x close parenthesis squared over n. So the capital N means the total population of the students or of the participants. Now let's go back to the previous table. So we have the 3 groups, the grammar-oriented, content-based, and email internet group or class. So from the formula, you will observe there is a symbol. Let's go back again. There's a symbol, summation of x2. So where is the summation of x2? x2. The summation of x2 is... Wait lang. Summation of x2 is... Ayun. Ito pala. Oh my gosh. Hirap. So the summation of x2 we can see here in the right. If you're facing the slide, it's in the right bottom of the table beside the N36. Okay, or after the n is equals to 36. So there is the summation of x squared. Now we have to substitute. Summation of x squared is 252,044 or 252,044. So we have to substitute. So we have the 252,044. Now we have to again substitute the value of summation of x. Summation of x. So where is the summation of x? So the summation of x is the total number or the summation of all the grades. Are these grades? Let's say these are grades of all the participants from the 3 groups. So we have the summation of x is equals to 3004. Okay. So for us not to square it again, we can just use the parenthesis summation x close parenthesis squared is equals to 9,024,016 at the bottom part of the left part of the table. The bottom left. What? Like that. So there. So we have to substitute it. There. And then, again, we have to substitute the n. What's the n again? So, we have the n, or the n is the total number of the data. So, we have 12 students and 3 groups. So, 12 times 3 is equals to 36. That's why we have 36. Okay? So, here's the calculation. So, 252,044 minus 3004 squared over 36. Of course, we have to simplify the number that has squared first. Is equals to 252,044 minus 9024, or 9,024,016 over 36. So let's calculate that. We have to divide first before we minus, because we're following the GMDAS, I guess. PEMDAS, so whatever. So we have the 252,044 minus 250,600, or 250,667.11. So we have to minus that. We will have 1376.89. So you take note of that our SST is 1376.89. Let's proceed to the next step. So the next step is we have to calculate the SSB. Let's go back to our terminologies. What is SSB again? The SSB is the sum of squares between groups. So a while ago, we calculated the sum of total squares. So this time, we will be calculating the SSB, or the sum of squares between groups. Sum of squares between groups. So so there. So the formula is SSB. So brace, we have to put brace because we will be using bracket, parenthesis rather, inside. So we have to look for the summation of x1 sub exponent 1, summation of x sub exponent 2, and 3, and so forth. So this summation of x sub exponent 1, 2, 3 are the summation of each data from each group. So we will see here in the table, from each group, there is a summation. So we have the x1. For the x1, we have the 989. For the summation of x sub exponent 2, we have the 101. And the summation of x sub exponent 3 is 1005. So if we are going to substitute that, the formula will be like this. So the 12 is the number of the data in each group. So each group has 12 data. So that's divided by the summation of x sub exponent 1, 2, and 3, and 4, so and so. So what we're just going to do is we will square them. So after we were able to substitute the groups, or the summation number of each groups, we will be substituting now the formula at the bottom, at the latter part, minus some can I just say we will substitute it? This is the formula, and then next step we will calculate the SSW, which is the formula is the SST minus SSB. So a while ago we discussed the SST, we get the 1376.89, and we also calculated the SSB, which is 20.05, and then we're just going to minus both, and we will have 1356.84. Next step. So after we calculated the SSW, or the sum of What's the SSW again? The sum of squares within groups. Very good. So after we calculated the sum, what's happening? After we calculated the sum, yes, keep on repeating, the sum of squares within groups, we will now proceed to the step 4, which is we have to calculate the degrees of freedom between and within groups. So the formula is degrees of freedom between is equals to k minus 1. What is k again? K is, what's k again? The number of groups. Very good. K is the number of groups, and n is the total number of data. So for the difference between, or the degrees of freedom between groups, we have the formula k minus 1. And the degrees of freedom within groups is the n minus k. So when we say n again, this is the number of data, and k is the number of groups. Okay, so let's solve it. So for the difference between groups, we have 3 minus 1. Why 3? Because we only have 3 groups. Okay, because k is the number of groups. Alright, very good. So 3 plus 1 basics is equals to 2. Next, we will now solve the difference between, within the groups. So again, we have the formula n minus k, and again, since for the, or n is, or means, the number of total data, and k is the number of groups. Very good. So 36, we just have to substitute 36 minus 3 is equals to, very good, 33. Next step, after we calculated the degrees of freedom between and within groups, we will now calculate the mean between and within groups. So a while ago, we calculated the sum of squares. We calculated the degrees of freedom. Now we will now calculate the mean. Okay, the mean between and within groups. Now we have the formula for the mean between groups. So for the mean between groups, it is equals to SSP over difference or degrees of freedom between groups. For the MSW, it's equals to SSW over degrees of freedom within groups. So a while ago, we already solved the SSP, okay, and the DF between, as well as the SSW and the DF between. Now we will just be substituting the data. So we have for the MSP, we have the 20.05 over 2. So that's equals to 10.3. For our MSW, we have 1356.84 divided by 33. So the answer is 41.12. Alright. So for all those calculated will be placed here in this specific table. So as you can see, a while ago, we discussed the sum of squares, the degrees of freedom, mean square values. Okay, now we will see how did we get the F ratio and the significance. Now, after we calculated the things that needed to be calculated, or the data itself, we will now be proceeding on how to use ANOVA within statistical logic. So as we all know, Turner follows 10 steps of statistical logic. So the first step is, of course, again and again, we have to state the formal statistic logic. So we have the null hypothesis. There's no statistically significant difference in the mean knowledge of English among the participants receiving one of the three types of ESL instruction. So we have to take note that the term in ANOVA should be statistically significant difference because we are looking for the difference between the groups. Next, we have the HARD alternative hypothesis. So there is statistically significant difference in the mean knowledge of English among the participants receiving one of the three types of ESL instruction. Now, step 2, we have to set the alpha. So the alpha is 0.05 or the 5%. Next, we have to select the appropriate statistics analysis of data. However, before we come into conclusion that we really need to use one-way ANOVA, there are assumptions or there are conditions that we need to check first. So, the participants are randomly selected from normally distributed population. So, if they are randomly selected, check that. Participants are randomly assigned to one levels of independent variable. So if the participants are randomly assigned to one levels of variables or independent variables, so check that. If independent is nominal and has more than two levels, so if the IV or the independent variable is nominal and has more than two levels, so perhaps, yes, we can use the one-way ANOVA. However, we still have to. So, the DV is interval in nature. So, the dependent variable is interval in nature. So, if the data are, or if your dependent variable is interval in nature, so, we have to use one-way ANOVA. And finally, if you were able to check this last one, this last checklist, or the last condition, you will definitely be using one-way ANOVA. So researchers seek to identify if there is probably a difference among the groups defined by the independent variable. So if the researcher is finding or wants to find out if the data has different or difference among the groups defined by the independent variable, therefore you will definitely be using one-way ANOVA. So now in our step 3, we were able to come into conclusion that we will be using one-way ANOVA. Now, step 4, we have to collect the data. Of course, we cannot start doing research without a data. So here is our data. Or here are. So these are the data. These, whatever. So next, step 5, verify the assumptions for the statistics are met. So we have to verify the assumptions. So from the book of Turner, she said that it's very important that as researchers, we have to verify all the data, all the assumptions, if they are met or not. Because if they're not met, what's the sense of using this kind of statistical tool? So these are the assumptions for ANOVA. Number 1, the levels of independent variable or variables contain exactly the same number of participants. So the participants are equal. If there is a 5 participant from the first group or from one group, there should be also 5 participants from the other groups. Okay? Number 2, the DV is interval or interval-like continuous, and the scores are normally distributed in the population in the group. So the dependent variable should be interval or interval-like. And of course, the scores should be normally distributed in the population of the groups. Number 3, there is minimum of 5 or 10 participants in each of the groups defined by the level of independent variables. So there should be 5. That's the minimum. And the maximum is, I don't know. What do you want? That's your maximum. Just make sure that it's smart. Okay. Next, step 6, calculate the F ratio. So a while ago, we have seen in the table that there is an F ratio, and then we did not calculate it in the first part. So here is the formula on how we calculate the F ratio. So F is equals to MSB over MSW. So a while ago, we discussed what's MSB and what's MSW. The mean squares between groups and the mean squares within groups. So we calculated that a while ago, and we come up with these answers. So we just have to substitute them. F is equals to 10.03 over 41.12, and that's equals to 0.24 or 24. So a while ago, you observed that there is a 0. 2.44. Oh my gosh. There is a 2.44. That's actually the, oh my gosh, bakit 2.4? Okay, so we have to validate that if my answer is correct. So that is 10.03 over 41.12. 10.03. So 10.03 divide 41.12. So we have the 0.24. Okay, I just forgot to include the other 4, but it's correct. That's right. So it should be, let's add, what's this? No. How can I edit it? So I will edit it later. Remember, this 2.44. Okay. Next, step 7. Determine the degrees of freedom for statistics and use DF and alpha to find the critical value of the statistics or calculate the exact probability. So we have to use the degrees of freedom and the alpha to determine the degrees of freedom, use the DFL to find so in this step 7, we have to find the critical value, and there are 2 ways. So we have to, the first way is we use the critical value approach. So the critical value approach is we have to determine first our degrees of freedoms between and within groups. So we already calculated that a while ago, so we have the answer 2 and 33. Next step, so we have to get the critical value. So how is that? So the DF within, in this table, we have to use, of course, the critical value of F for 0.05 significance level. I provided it in the written report. You already have this table, and here in the PowerPoint, I also provided it for you. So the DF, let's go back. Our DF within is 33. Our alpha is 0.05. So this is the table for that. So the DF within is 33. So let's find out where is 33. So the 33 is the 30, the last number at the bottom, and then our DF within, our DF between is 2. Okay, so we're going to look at the column 2 and the row 33. So the answer is 3.29. Now, let's remember that 3.29. And our F ratio is 0.2439 or 0.244. And our, so wait lang. So our critical value now is 3.29. Okay. Now, next step, we have or the next approach, we have using the exact probability approach. So in using the probability approach, or in calculating the probability approach, you will be using the P program, or if you have statist or SPSS, you can also use that, and you need to solve that in the computer. Yes, to find the probability approach. So we have the F ratio, the value of F ratio 0.2433 or 2.439, or the 0.244, and our p value 7 point or 0.785. That is already given in our table there. Okay. Next, we have to interpret the outcome of the analysis. Compare the observed value in the critical value, or compare exact probability to alpha. So we have to compare the observed value and the critical value, or we have to compare the exact probability which is solved, or which can be solved in the SPSS, and the alpha. So here is the first method, or the first approach rather. So in using the critical approach, the rules for comparing is F observed and F critical is equals to no. So here's the rules of comparing. If F observed is less than critical value, accept the null. If F observed is greater than critical value, reject the null. So let's see the value. So F observed and F critical value, we compared. When F observed and F are compared, we see 0.439, which is our F observed, or our F ratio, is less than 3.30, which is our F critical that we looked in the table a while ago. So 0.2439 or 244 is less than 3.30. Therefore, we come to conclusion that HO, or the null hypothesis, is accepted. So again, we have to recall that our null hypothesis is there is no statistically significant difference. Okay, now let's see if the approach are the same. Let's see. So using the exact probability approach, so here's the rules for comparing the exact level of probability. For F observed, let it be confused. The F observed is also the F ratio. Okay. F observed to alpha. So we're just going to compare the 0.244 to alpha. So if exact probability it should be, yeah, the exact probability. Forever. Alright. So we will be using the exact probability. Yeah, the P. So if exact probability is greater than alpha, accept the null and reject the alternative. If exact probability is less than alpha, we have to reject the null and accept the alternative hypothesis. So we have to see our probability, or our p-value a while ago is 0.785, and our alpha is 0.05. So which is greater, probability or alpha? So it's the p-value, or the exact probability. So we have to accept the null hypothesis, same as in the previous approach. We accepted the null hypothesis. So either of the two approach, you can use that. Step 9. So we have to interpret the findings now. So here's how we interpret the findings. There is 95% certainty that there is no statistically difference in the mean knowledge of English among the participants receiving one of the three types of ESL instruction. So as you can observe, the sentence or yes, the sentence is just like the null hypothesis, but we included that the 95% certainty, okay, which we have 95 because of the 5% alpha. Okay. All right. So after that, we have to interpret the meaningfulness of the findings. So in the book of Turner, you can see how she interpreted the meaningfulness of the findings. She included the critical value, the difference, the mean squares, the mean squares between, the mean squares within, what are the values that you got. When you interpret the findings from using the critical value approach and the exact probability approach, what did you got, what conclusion you have. So that's how you will be interpreting the meaningfulness of the findings or the findings itself. So that would be all. Thank you so much.